Hello and welcome. In this lecture, we will learn about different encryption algorithms and how they works. So, let's start our topic.
Hi, I am Imran Afzal. I make learning technology easy, even for beginners in IT. So I have over 25 years of experience in Linux administration, Windows, virtualization, and many more. I have taught millions of students worldwide.
We will start with data encryption standard. Well, data encryption standard is an old-school encryption method that was widely used to protect data back in the late 20th century. IBM developed it in the early 1970s, and it became a federal standard in 1977 by the United States National Institute of Standards and Technology. It uses a 56-bit key, which was considered secure at the time of its introduction. However, advancement in computing power have made DES relatively easy to break using brute force attacks. It encrypts data in 64-bit blocks using a series of 16 permutations and substitutions rounds to transform the plain text into ciphertext. Even though it has been replaced by more secure algorithms like advanced encryption standards, DES was a key player in the evolution of modern cryptography. DES was widely used in various real-world applications, such as encrypting ATM pins and transactions in banking systems to protect against theft. It played a crucial role in safeguarding sensitive data for governments and businesses in secure communications. So, despite being largely replaced by more secure algorithms, some older systems and hardware still utilize DES. Advanced Encryption Standard. Well, the Advanced Encryption Standard, AES, is like the modern superhero of encryption, which ensure that our sensitive data stays safe. It was introduced by the United States National Institute of Standards and Technology in 2001. It replaced the older and less secure data encryption standard. So, as a block cipher, AES encrypts data in fixed blocks of 128 bits and supports three key sizes: 128, 192, and 256 bits. So, the longer the key, the stronger will be the security. AES is known for being fast, secure, and efficient. This makes it perfect for various applications, like secure web communications, also encrypting files with tools like BitLocker, and securing wireless networks, and protecting messages on apps like WhatsApp. For example, if you encrypt the plaintext with a 128-bit key, AES will transform it into a secure, unreadable ciphertext through its systematic rounds of operations. So, thanks to its reliability and versatility, AES is recognized as a standard for modern encryption, and it is trusted to keep everything from personal messages to top-secret files safe. Diffie-Hellman key exchange. Well, imagine you want to share a secret key with someone over the internet, but you're worried about security. The Diffie-Hellman key exchange, invented by Whitfield Diffie and Martin Hellman in 1976, this symmetric algorithm allows you to securely share this key, even if the communication channel is insecure. Here's how it works. The Diffie-Hellman key exchange can be likened to you and a friend wanting to create a shared secret color for secret communication while being in separate rooms and only able to exchange colors through a potentially untrustworthy messenger. So, to start, both of you agree on a common starting color, that is the public color, and a mixing color, like blue paint, which are known to everyone including the spy. Each of you then secretly chooses a private color, mixes it with the public color to create a new color. That is called the public mix, and sends this to each other through the messenger. When you receive your friend's public mix, you add your private color to it, while your friend does the same with your public mix and their private color. The magic happens when both of you end up with the exact same final color. Now you have shared secret. The spy, aware only of the public colors and mixes, cannot deduce the final secret color without knowing your private colors. Similarly, the Diffie-Hellman key exchange uses mathematical numbers and operations instead of colors to securely share a secret key over an insecure channel, ensuring that only the intended parties can understand the communicated messages. Rivest Shamir Adelman. Well, RSA is an asymmetric encryption algorithm that uses two keys, a public key that anyone can have and a private key that must be kept secret. Its security is based on the challenge of factoring the product of two large prime numbers, which makes it highly secure. RSA is versatile and is commonly used for secure data transmission, digital signatures, and key exchanges. It typically utilizes key lengths of 2048 or 4096 bits for strong protection. Here's how it works. First, RSA generates two keys, one public and one private, using large prime numbers and some complex math. So, when someone wants to send a secure message, they use the receiver's public key to encrypt the message. The receiver then uses their private key to decrypt and read the message. This process ensures that even if someone intercepts the encrypted message, they can't read it without the private key. This strong security and versatility have made RSA essential in modern encryption. Quantum key distribution. Well, quantum key distribution is a super secure way for two people to share cryptographic keys by using the principles of quantum mechanics. It works so well because if anyone tries to eavesdrop, their presence is immediately detected. That makes it much more secure than classical methods. QKD is incredibly useful for protecting highly sensitive information, such as financial transactions, government communications, and military data, because it offers a level of security that's hard to beat. Even though this technology is still pretty new and developing, it holds great attraction for making our future communications safer than ever before. Two-Fish. Well, Two-Fish is a symmetric key block cipher with a block size of 128 bits and a key length of 128, 192, or 256 bits. It's optimized for 32-bit CPUs, and the algorithm is open source and available for free. Two-Fish uses an S-box, which is pre-computed, key-dependent substitution box that makes it harder to break the encryption, but it still relies on the cipher key to decrypt the data. Elliptic curve cryptography. Well, ECC is an asymmetric cipher that uses algebraic functions to create security between key pairs. It is faster and more efficient, provides similar levels of security like RSA, but with shorter keys. So, this makes ECC a good choice for devices with limited computing power, like IoT devices. Well, I hope you have understand the concept, and I will see you in the next lecture.
I hope you learned something useful in this video, and I will see you in the next one. But wait, please don't forget to subscribe.